I thought I would go ahead and make a quick video about a couple things from Module 2 assignment. So I actually grabbed a few of the homework problems, and I'm going to walk you through them. So from section 2.2, number 7 was solved by Gaussian elimination to put the augmented matrix into row echelon form, and then back addition to put the matrix into reduced echelon form. All right, so we have these three equations. Here's the first augmented matrix. So I was hoping that you would go through and tell me what row operations you did and go along that way. So here are the steps I took as the book and the lectures described. You can do this multiple ways, but by the end you should get to the same final reduced form. So you can see all these different things that I'm doing, right? And then by the end we have the final reduced part where we have x is equal to 1. So x, here's the first column. On the right hand side is 1. Y, all right, the only 1 in that column, is equal to 0, the right hand side. And then z, our final variable, is equal to -1. Now what I'm also hoping that you're starting to do is to check it with R. So you've had your R course, or you've have enough knowledge that you didn't have to take the R course. So I'm going to show you, here's a couple different ways to do it. This is what I consider the most straightforward way, but it's not the only way. So I create a matrix. I tell it how many columns, and I said it was by row. So I put the entries in by row. I put a little space in between each of those to tell me that that was the next row. I knew I had 3 columns, right? I go ahead and then usually go ahead and spit out A to make sure it looks like it's supposed to. B then is the right hand side, and usually it's a column matrix or a column vector, right? Here it doesn't matter. I don't have to tell them that it's a matrix with 1 column and 3 rows. I can just give it a vector, right? Then I just call solve A comma B, and I get 1 0 -1, which is what we got up here. So hey, I did all the row operations correctly, right? So another way to solve this is to first find the inverse, which you do by just calling solve just on the matrix on A, and then do matrix multiplication, which is what those percent signs around the star mean, with B. And notice here I get a 1 e to the 0, 0, that's a 1. I get 2.7555 e to the -17, that is a 0, right? You move the decimal place 17 places to the left, so there are 16 zeros in front of this too. That's rounding error. So it's because I took the inverse first and then did it that it's rounding. And right here we see a -1 also. Right? There's always other ways to do things. Another way that you may have done previously, or you may think is more, or is a little bit easier, is to first define all 3 rows into their own variable. So row 1, row 2, row 3, and then R bind it, which R stands for row. I'm binding the 3 rows, and then I spit it out again. I called this one other A, and then I solve it. Right now, that's all good and well, right? We can check our final work, which is good. Now there is there's a package called MATLib for Mathematics Library for R. So first you have to install it. So you can just install it through RStudio very easily. Then load the library. And I already have A and B in memory from before because it's right up above. So we can call echelon, which is a function that's built in. And again, this library is only really for educational purposes, so you shouldn't really be doing this to solve big matrices. So I have A, B. I say reduced, I'm going to do false, but I'm going to do verbose as true and go ahead and do fractions as true. So this will not put it in reduced row echelon form, but it will put it in row echelon form. So the 4th column here is going to be my B, and so it tells me what the initial matrix is. It works on row 1, it multiplies row 1 by 1/2, it subtracts row 1 from row 3, right? And then next it goes to row 2, it tells me what it does, right? Row 3, what it does. So I get all zeros in the bottom diagonal, all right? So then I could back substitute. So here we see that z is equal to -1, which we had seen before. Then I could back substitute into those if I wanted to. Or I'm going to go ahead and get rid of the reduced equals false. By default it's true. But I'm going to keep it verbose so I see every step. And I'm going to keep it on fractions for fun. Right, so now it goes through, it does all the similar stuff that it had done before. Right, we get down to here. This is where it stopped last time. And now it's going to go ahead and say, well, I'm going to multiply by a 6 and subtract from row 1. So now it's getting rid of these values up above, right? And finally we get down into reduced row echelon form with a 1 in each of the 3 columns. And we see again, this is what we ended up with when we did it by hand. So hopefully you're able to do that. Right? So that is a nice way to check your work for some of these row manipulations. Now, when we want to figure out, so from section 2.3, I think this is number 1, I can't remember. We have 3 equations, right, and we want to show that they're inconsistent. So when I do that, right, I do some matrix manipulation, some row reductions, and I get all zeros on the left-hand side and a coefficient on the right-hand side that is not 0, so that means it's inconsistent. Right, it's a contradiction, so it's inconsistent. We can do the same thing with echelon, with that function. So I create a new matrix. I called this one Z, just so it wouldn't overwrite the other one. Called the right-hand side, RHS. And I said, let's do echelon, verbose true, fractions true. And it tells me what the initial matrix is. It starts, it exchanges 1 and 3. I don't remember what I did up above, right? So it is very possible that this thing is going to do different row operations than what I do, and I'm pretty sure it does. And then what we see is that by the time we get down here, we get all zeros on the left-hand side. Remember, the 4th column is the right-hand side, and an 8 on the right-hand side. So it gets a different form at the bottom than what I got, which is perfectly fine. It's still, it did different row operations, so that might happen. But again, we can still see that it is inconsistent. Right? Now, the other fun thing that you had to do was graphing planes. I tried not to take off points if you at least attempted to graph the planes. I think they're a pain to do, personally. I have these 3 equations, and so there'll be 3 planes. So I go ahead and I did it in R. One way is to use the RGL library. It's easier than some other stuff. Plotly is also a good package that you could use as well, but it has a steeper learning curve. And you can read through the code if you're really interested in how I did this. But basically, because I'm in the first quadrant, right, I can use triangles 3D. I plot the points and then the triangles around them. Put them in different colors for purpose. If you're colorblind, sorry about that. So I did it, and then once what RGL does is opens up its own window device, and then you can move it around by dragging the mouse. Now it doesn't interact interactively with RStudio when you're doing it, so I had to manipulate it, save screenshots, and save them as PNGs and put them into the Markdown document. All right, so here's kind of the orientation that the book likes to use, where X is coming out in front of you, Y is going to the right, and Z is going up. All right, and we can see I colored each of them differently. I gave them some opaqueness, so the blue looks like it's purple, that kind of stuff. Here's a different perspective. Right, so now let's see, which color was the axis back here. So Z is blue, green is X. So X, Z is still up, Y. But what I've done now is I've shifted it around so you can kind of see that these 2 planes right here are parallel. That's why the system is inconsistent, so that these two planes going this direction are parallel. All right, so we will not have an intersection of the three. And here's a yet another. Right, this time I have X going back Z still going up. I keep Z up most times and Y going to the left. So, you can try to play around with that if you're interested in learning how to graph in 3 dimensions in R. So hopefully that helps you at least be able to check some of your work as you're going through these steps.